we will talk a little bit about the installation of HBase, a quick intro and a few commands to work with HBase, and also I will present you the distribution of Hadoop we are going to use for this training course, because it is not the purpose of the course to lose a lot of time installing the HBase. So because there are different distributions out there that offer all these components integrated, it is very good to use this for testing purposes and also in a production environment. So, as you may already know, HBase is built on top of Apache Hadoop and Apache Zookeeper. Like the rest of the Hadoop ecosystem components, it's written in Java. HBase can run in 3 different modes: standalone, pseudo-distributed, and full distributed mode. The standalone mode is what we'll work with through the course. That means you're running all of HBase in just one Java process. This is how you'll interact with HBase for exploration and local deployment. For the purpose of this course, we will use Hortonworks distribution of Apache Hadoop, and in this one node deployment, we will basically use a pseudo-distributed HBase environment. That is, however, transparent to us because it doesn't influence the way we are working with it, but nearly the performance of the jobs we run on it. The last deployment configuration is fully distributed across a cluster of machines. The other modes require dependency packages to be installed and HBase to be carefully configured. So, let's jump into it and let me show you how to download and install the Hadoop distribution of the Hortonworks distribution of Hadoop in the form of the sandbox. So I'll exit the slides and go to my browser, where you can see this is the Hortonworks website. On this website, in products, we can find the downloads, and here there are a number of install guides for the different products that Hortonworks offers. So we will install the Hortonworks sandbox, which comes in the form of a preset virtual machine out of the box. So if we go to more about the sandbox, we can see what it contains. It contains the Apache Hadoop and other base components, and it also includes the HBase, our focus on this training course. So if we go to download and install, we can see that there are different versions of the sandbox for different platforms. So if you're using a VirtualBox, you can download this image, or if you're using VMware or Hyper-V, the other ones. I earlier downloaded the VMware version because that's what I use for this demo, and I will show you now how to import this image to your infrastructure. So let me connect to my VMware installation. So go with root and the password, and just a few moments. Probably you know that the VMware vSphere client is only working on Windows platform, so I'm running on Windows 7 VM on coherence mode, so I can access the platform. You can see that I already have the Hortonworks sandbox over here running, but let me show you how to import this machine. After you download the image from the Hortonworks website, you can go to File and Deploy OVF template. And if we browse, you just have to go to the file that you download, click on Open, and just go through the basics with next, the name, the disk format that you want to use, and I'll just cancel here because then we'll have already to complete and I won't be able to cancel this anymore. And the virtual machine will be deployed in about 20 to 30 minutes. After the machine is deployed, I recommend you to go to the settings, and I gave the virtual machine 8 GB of RAM and also 4 virtual processors. The 8 GB of RAM is the recommended for using HBase, and also I recommend you to use at least 2 cores on 2 different sockets, so a total of 4 cores, 4 virtual processors for this VM. Okay, so after you have your machine up and running, you can just go to the console and you will see the IP address that was automatically given to you by the DHCP server if you have one available. If not, you can log on to this virtual machine and configure it by yourself, because this is based on a CentOS Linux system. So now we'll go back to the browser and go to this address. So this is the address. I reload this just to show you that everything is in order, and we will have to go to the IP address associated with the sandbox and to go on a certain port that is 8000. As you can see here, we have the components that are installed on the sandbox, and by default the Ambari server component will come as disabled, so you'll have to click on enable and wait for a few moments. I already enabled this a few minutes ago, so Ambari is already enabled on my sandbox. The next thing you have to do is open another page, and in this page use the same IP address but change the port to 8080, which is the port that is used by Ambari. So now you can see that Ambari is a tool that shows all the metrics for the sandbox. So basically on the left side you have all the components, and you can see if there are any warnings. And in the other tabs, you can see any other associated problems that are specific to your cluster. My mouse disconnected for a few moments, but it's back on now, so hopefully there won't be any problems. So back to the dashboard, we'll go to HBase, and you can see that everything is in order. When I first started the sandbox, I had some problems with HBase, with the master server, and also with Storm, which is not the focus of our training course. But just to let you know how you can resolve these problems, basically you'll have to go to the upper right side to service actions, and you can just stop the services and start them, or just restart them all, and 99% of the time that will solve your problem. Okay, so now that we see that HBase and also all our other components are working properly, we can now start working some commands in HBase. Okay, so let me go back to my IP address with the port 8000, and here most of our work will be made using the Hue shell. So after we go to the Hue shell, we can click on the HBase shell, and this will open a shell where we can type commands exactly like in the console of HBase shell. Okay, so the first command we're going to use is to list all the contents of our HBase server. HBase uses the table as the top level structure for storing data. To write data in HBase, you'll need a table to write into. To begin, we will list to see if we have any components right now, and then we will create a table called myTable with a single column family. So list, and we can see that we just have one table that is the top level table, and also there's a test table that Ambari creates by default, which is Ambari smoke test. So we will just ignore those two and create our first table with the command create myTable and we will use the single column family. Okay, so now if we list, we can see that we have the new table. With the table created, you can now write some data. Let's add the string hello HBase to the table. In HBase parlance, we say put the bytes hello HBase to a cell in my table in the first row at the column family message column. Catch all that? Again, we'll cover all this terminology in the next chapter. For now, we can just perform the write, put myTable and you can see that it actually tries to help me as I type. I'll put first and CF column message, and the message hello HBase, and hit enter. So let's see if that worked well. And we can see that with get my table and first. So now if we scroll up a little, oh sorry, I forgot to put comma between those two. So one more time. There's an unknown table because it changed the name from my table to mutable. So this is get my table first, and it says 0 rows because basically it didn't register what I asked of him, because here also it changed my table to mutable. So one more time, put this, and it's okay, I think, this time, and get okay, and we have our first row in the table. Okay, so now that was pretty easy. HBase, you'll have to know that stores numbers as well as strings. So let's go ahead and add a couple of more values, like so. Put in my table, and this time let's make sure that my Mac doesn't autocorrect that to mutable, to second, and we'll put the CF as faux and the number 0x0, and go. And let's add another one that says put in my table, not mutable, my table. I said my table. Okay. Third, with CF being bar and the number of, actually the approximation of pi, which is 3.14159, and that's enough. Okay, so we'll put this, and now we have 3 cells in 3 rows in our table. Notice that we didn't define the columns before we used them, nor did we specify what type of data we stored in each column. This is what the NoSQL crowd means when they say HBase is a schemaless database. But what good is writing data if you can't read it? No good at all, I think. It's time to read back our data. HBase gives two ways to read data: get and scan. As you undoubtedly noticed, the command you gave HBase to store the cell was put. Get is the complement of put, reading back a single row. Remember when we mentioned HBase having a key value API but with a twist? Well, scan is that twist. But we will explain how scan works in chapter 2 and why is it important. In the meantime, let's focus on just using those commands. So let's get and my table. Probably if I don't click this X, I'll have a lot of nightmares with this mutable. And first, hit enter, and you can see that it responded to me with the column cell, which is the column family message with the timestamp at the value hello HBase, our first value in this database. So just like that, we pulled out our first row. The shells show us all the cells in the row, organized by column with the value associated at each timestamp. HBase can store multiple versions of each cell. The default number of versions stored is 3, but is configurable. At read time, only the latest version is returned unless otherwise specified. If you don't want multiple versions to be stored, you can configure HBase to store only one version. There is no way to disable this feature. Use scan when you want values from multiple rows. Be careful. Unless you specify otherwise, it returns all rows in the table. Don't say I didn't warn you. So scan my table and hit enter. As you can see, we have our first column with the value hello HBase, our second column with the value 0 given in hexadecimal, and also our third column with the approximate value of pi. So all our data came back. Notice the order in which HBase returns rows. They are ordered by the row name. HBase calls this the row key. HBase has a couple other tricks up its sleeve, but everything else is built on the basic concepts we've just used. So, at the end of this first chapter, let's wrap it up. We covered quite a bit of material for an introductory chapter. Knowing where a technology comes from is always helpful when you're learning. By now, you should understand the roots of HBase and have some context for the NoSQL phenomenon. You also understand the basics of the problem HBase is designed for, as well as some of the problems HBase has solved. Not only that, but you're running HBase right now and using it to store some of the most precious Hello World data. Next, we will get into much more complicated stuff in chapter 2. I thank you very much for your attention, and I hope that we'll continue with chapter 2 of this training course. So, thank you and goodbye for now.